Picture this. You are holding your phone. Maybe you have been holding it for the last hour. Maybe you picked it up the moment you woke up this morning, before you said a single word to another human being. Now look at it. Inside that device, behind the screen you are staring at, is a battery. And inside that battery is a metal that is older than the sun, not older than your country, not older than civilization, older than the solar system itself, older than the Earth, older than every planet orbiting every star in this galaxy, older than the stars themselves. The lithium in your phone was forged in the first 3 minutes of the universe, when the entire cosmos was smaller than the period at the end of this sentence, and hotter than anything that has existed anywhere since. Every other metal you have ever touched, iron, gold, copper, silver, was made inside a dying star billions of years after the universe began. Lithium was there before any of those stars existed, before any planet, before any galaxy, before light had anywhere to travel to. That is not a metaphor, that is a measurement. And right now, the world is tearing apart one of the most remote deserts on Earth to get more of it, paying the people who live above it almost nothing, and calling the whole process the clean energy revolution. You have heard that story before. The details are different, the structure is identical. Here is where lithium actually came from, and what that origin explains about everything happening to it right now. The first 3 minutes. Before we get to the desert, we need to go back further than any other resource story goes. Further than the pyramids, further than the first human, further than the first fish, the first cell, the first molecule of oxygen in Earth's atmosphere. We need to go back to before the Earth existed at all. 13.8 billion years ago, the universe did not exist. Then it did. In the first second, the temperature of everything reached 10 billion degrees, and the entire observable universe was compressed into a space you could not see with the naked eye. In those conditions, physics worked differently than anything you have experienced. Protons and neutrons existed but could not yet combine into atoms. The energy density was too high. Any nucleus that formed was immediately torn apart by the radiation surrounding it. For the first 100 seconds, the universe was an ocean of particles moving at nearly the speed of light, colliding and annihilating and reforming with no structure of any kind. No atoms, no molecules, no chemistry, nothing that could be called matter in any sense you would recognize. Then, between 100 seconds and 17 minutes after the Big Bang, something shifted. The universe had expanded enough that temperatures dropped into a range where nuclear reactions could proceed without immediately reversing. Protons began fusing into helium nuclei. And in the final moments of that window, before the temperature fell too low for fusion to continue, a small fraction of those reactions produced something else. Lithium-7, the isotope that makes up 92.5% of all the lithium on Earth today. The window lasted less than 15 minutes. When it closed, the universe had produced exactly 3 stable elements: hydrogen, helium, and lithium. And it would not produce another for approximately 200 million years when the first stars finally ignited. Every element heavier than lithium, carbon, oxygen, nitrogen, iron, gold, uranium, was made later, inside stars, through processes that required millions of years of stellar evolution, followed by violent supernova that scattered their contents across galaxies. Lithium needed none of that. It was made in 15 minutes at the beginning of everything, before a single star had formed to make anything else. And here is what that means in practice. Right now, somewhere in the world, a lithium battery is being assembled in a factory. Workers handle the material with gloves because raw lithium reacts violently with moisture in the air. Quality control systems verify the purity to the gram. Shipping manifests track every kilogram. The entire operation runs on the assumption that lithium is an industrial input, a commodity, a raw material, something to be processed and priced and moved. None of those workers, none of those systems, none of those manifests mention that the material passing through their hands is older than the sun, that it existed before the Earth formed, that it was created in a window of 15 minutes at the beginning of time, in conditions that have not existed anywhere in the universe since. When you hold a lithium battery, you are holding one of only 3 elements that existed before the first star in the universe ever ignited. The other 2 are hydrogen and helium. You cannot hold those. Lithium is the only primordial element you can pick up. That is what is in your phone, and that is only the first strange thing about it. The problem, nobody can explain. Here is where the story gets strange in a way that most science communication skips over entirely. When cosmologists calculate how much lithium the Big Bang should have produced, using the same equations that correctly predict the ratio of hydrogen to helium in the universe, equations verified by independent measurements across decades, and then measure how much lithium actually exists in the oldest stars, the numbers do not match. The oldest stars in the universe contain roughly 3 times less lithium than the standard model of Big Bang nucleosynthesis predicts should be there. 3 times less. Not a rounding error, not a measurement artifact. 3 times consistently across every ancient star that has been measured. This has a name. Cosmologists call it the lithium problem, and it has appeared in peer-reviewed literature since the 1980s without a resolution the scientific community has accepted. The explanations proposed over 4 decades include undiscovered stellar processes, physics beyond the standard model, and the possibility that some fundamental constant of the early universe differed from what current equations assume. None has been confirmed. The most strategically important metal in the clean energy economy does not fully behave the way our best understanding of the universe says it should. That discrepancy has never made a headline. It has been sitting in the scientific literature for 40 years, and the companies mining lithium in the Atacama have never mentioned it once. But here is what connects that cosmic anomaly to a hospital ward in Melbourne in 1949, and why that connection matters for everything that follows. John Cade had spent 3 years as a prisoner of war in Changi Prison in Singapore, watching men lose their minds under conditions of starvation, disease, and violence. When he returned to Australia after the war, he was assigned to a small psychiatric hospital called Bundoora on the outskirts of Melbourne, a place where patients with severe mental illness were warehoused rather than treated because no effective treatment existed. He had no research budget, no laboratory, no institutional support of any kind. He worked in a converted kitchen next to the ward, alone, in the evenings after his clinical duties were finished, using equipment he built or borrowed himself. His theory was simple and completely unverifiable with the tools he had. He believed that manic episodes were caused by a toxic substance produced by the body. He had no idea what that substance was. He started testing compounds on guinea pigs, working through a list of candidates systematically, with no particular reason to think any of them would work. When he tested lithium salts, something happened that he had no framework to explain. The guinea pigs became calm, not sedated, not unconscious, calm, responsive, present, but no longer agitated. He had never seen anything produce that effect before, because nothing had ever produced that effect before. He tested it on himself for several weeks before he administered it to a patient. The first patient was a man named Bill Brand, who had been in a continuous, severe manic state for 5 years. He had spent most of that time in restraints. He could not hold a conversation. He could not recognize his family. Within 3 weeks of receiving lithium, he stabilized. Within 2 months, he left the hospital and returned home. Cade published his findings in 1949. The paper was ignored for a decade. The psychiatric establishment did not trust results from an unknown doctor working in a converted kitchen in Australia. Lithium was also unpatentable. It was a naturally occurring element, which meant no pharmaceutical company had a financial incentive to fund the research needed to validate it. It took until the 1960s for lithium to be accepted as the first effective pharmacological treatment for a major psychiatric condition in medical history. The same element the universe produced in 15 minutes at the beginning of time, and that our best cosmological models still cannot fully account for, turned out to be the thing that could stabilize the human mind at its most extreme. A man who had watched prisoners lose their minds in a camp in Singapore spent his evenings alone in a converted kitchen and found it, working with no funding, no support, and no reason to believe he would find anything at all. Nobody planned that, nobody predicted it. It is simply what the element is, and the story was not finished, not even close. The metal that almost wasn't. For most of human history, lithium did not exist as far as anyone knew. Gold was known to every civilization that ever left a written record. Copper was smelted 8,000 years ago. Iron defined an entire age of human development. Lithium was not isolated as an element until 1817, when Swedish chemist Johann August Arfwedson was analyzing a mineral called petalite from a Swedish island and noticed something in its composition that did not match any known element. He brought his finding to his mentor, Jöns Jakob Berzelius, one of the founders of modern chemistry, who named the new element lithium from the Greek word for stone, lithos, because unlike sodium and potassium, both discovered in organic matter, this one had come from rock. Arfwedson never managed to isolate pure lithium metal. That took until 1821, when William Thomas Brande produced a small quantity through electrolysis. The sample was too small to weigh accurately. For the next century, lithium remained a laboratory curiosity, interesting to chemists, useless to industry, present in trace amounts in mineral springs that certain physicians believed had therapeutic properties without understanding why. Then, John Cade found what it could do for the human mind. Then, in 1980, a chemist named John Goodenough, he was 57 years old, an age at which most scientists have done their best work, published a paper describing a lithium cobalt oxide cathode that could store and release electrical charge with an efficiency no previous material had achieved. A researcher named Akira Yoshino used that discovery to build the first prototype of the modern lithium-ion battery in 1985. In 1991, Sony commercialized it. The battery stored more energy per unit of weight than any previous technology, recharged hundreds of times without significant degradation, and could be manufactured at a scale that made portable electronics economically viable for the first time. Within a decade, lithium-ion batteries were in every laptop and mobile phone on Earth. Within 2 decades, they were the foundation of the electric vehicle industry. Within 3 decades, they were the central component of the global energy transition. In 2019, John Goodenough won the Nobel Prize in Chemistry for his work on the lithium-ion battery. He was 97 years old, the oldest Nobel laureate in history. He had spent 40 years watching the technology he helped create become the infrastructure of the modern world. The element nobody knew existed in 1816 became the element the 21st century cannot function without. That transition happened in approximately 200 years. Gold has been strategically important for 5,000. The world did not have time to build the institutions or the governance frameworks that might have managed lithium's rise differently. It arrived too fast, and the architecture already in place, the one built for oil, for copper, for cobalt, simply absorbed it, without modification, without resistance, and without anyone who had the power to change it feeling any particular need to do so. The desert that should not exist. Come back to Earth now, not to a laboratory, not to a factory, to a place where the ground temperature exceeds 60 degrees Celsius in the afternoon, where the air at 3,600 meters above sea level is thin enough that visitors lose coordination within hours of arrival, and where some weather stations have never recorded a single drop of rain in the entire history of meteorological observation. The Atacama Desert in northern Chile. Nothing grows here beyond the occasional thorn bush adapted to conditions that would kill almost anything else. No rivers, no trees, no sound except wind moving across salt and volcanic rock. This is where the element forged at the beginning of the universe ended up in its highest concentration on Earth. And the reason it ended up here comes down to geology operating on a timescale that makes human history look instantaneous. The Atacama sits at the collision zone of the Nazca and South American tectonic plates, one of the most geologically active regions on Earth. That collision built the Andes over the past 25 million years. The Andes created a closed basin by surrounding it with mountains high enough to block moisture from the Pacific and trap any water that fell inside. The volcanic activity introduced lithium-rich minerals into the groundwater through hydrothermal processes operating over millions of years. The extreme aridity prevented the water from escaping before the lithium could concentrate. Everything had to work together in sequence over an almost incomprehensible span of time. Under the salt crust of the Salar de Atacama, a salt flat covering 3,000 square kilometers, sit brine pools that formed as ancient seas evaporated and concentrated their dissolved minerals over millions of years. The lithium concentration in that brine is approximately 65 times higher than average seawater. The Atacama Triangle, northern Chile, Bolivia, and Argentina, holds an estimated 58% of the world's known lithium reserves. The Salar de Atacama alone accounts for roughly 40% of current global lithium production. It took 10 million years to accumulate. The world intends to extract most of it in the next 30. The Atacameño people, the Licanantai, have lived in and around this desert for thousands of years, building irrigation systems from the same underground water sources that lithium extraction now draws from. Studies published between 2022 and 2024 documented measurable drops in brine levels and vegetation loss around active extraction sites. The flamingo populations that nest on the salt flat, 3 species, one of which nests almost nowhere else on Earth, have shown population stress indicators that researchers linked to wetland shrinkage. The companies operating the extraction sites dispute the causal connection. The brine levels continue to drop. The flamingos continue to decline. The lithium continues to leave. And what happens to that lithium once it leaves is where the story stops being about geology and starts being about a system that has been running for a very long time. The commodity trap, again. In 1904, a British company called Tanganyika Concessions secured mining rights across a vast stretch of what is now the Democratic Republic of Congo and Zambia. The terms were straightforward. The company would extract the copper, the local population would provide the labor, and the profits would flow to London. The people living above the deposit would receive wages. The people in London would receive everything else. 120 years later, the structure of that arrangement is still running. The names have changed, the element has changed, the direction of the money has not. Chile sits above the largest accessible lithium deposit on Earth. In 2022, at the peak of the lithium price cycle, Chile's effective revenue from lithium extraction, royalties, taxes, and state company participation combined, represented approximately 4 to 6% of the final value of the lithium products sold on international markets. The same lithium processed into battery-grade lithium hydroxide in China, which controls roughly 60% of global lithium refining capacity and 85% of lithium battery component manufacturing, sold at margins that made the extraction royalty look almost meaningless. China does not mine most of the world's lithium. China processes most of the world's lithium. And in the gap between those two activities, between digging something out of the ground and turning it into something a factory can use, almost all the value is created. Chile receives the raw material price. China captures the processed material price. The ratio between those two, at various points in the lithium market cycle, has exceeded 20-to-1. This is the commodity trap. Raw material leaves, finished product returns at a price the extraction country cannot afford to pay for its own resource. The wealth accumulates in the countries with the processing infrastructure, not the countries with the deposits. Bolivia holds the largest single lithium deposit on Earth, the Salar de Uyuni, with an estimated 21 million tons of lithium, enough to supply global demand for decades. Bolivia is one of the poorest countries in South America. The connection between those two facts follows the same logic as the connection between the Congo's cobalt wealth and the Congo's poverty, and the connection between Africa's mineral reserves and Africa's income per capita. Having the resource is not the same as capturing its value. It has never been the same. And the architecture that separates those two things, the transfer pricing mechanisms, the processing monopolies, the trade agreements that locked extraction countries into raw material export roles before they had the industrial base to negotiate differently, was not constructed by accident. It persists because it works exactly as designed for the people who designed it. John Goodenough spent 40 years watching lithium-ion batteries change the world. The Licanante have spent 40 years watching the water table drop beneath the desert their ancestors built irrigation systems in. Both were present for the same transformation. The distance between their experiences of it is the distance the commodity trap creates and maintains, deliberately, at scale, across every resource extraction cycle in modern history. The element is different every time. The distance stays the same. The clean energy paradox. Here is the contradiction the entire lithium story rests on. Not a subtle contradiction, not a matter of interpretation. A structural contradiction sitting at the center of the most important industrial project of the 21st century, visible to anyone who looks directly at it. The global transition away from fossil fuels runs almost entirely on lithium, extracted from a handful of locations under conditions that reproduce the extractive logic of the fossil fuel economy it is supposed to replace. The International Energy Agency projects that lithium demand will increase between 40 and 50 times by 2040 to meet stated climate targets. 50 times. The supply to meet that demand is concentrated in 3 countries in one region of South America, with secondary deposits in Australia and a small number of other locations. The companies building the clean energy future operate at the same scale, with the same financial structures, and through the same commodity supply chains as the companies that built the fossil fuel economy. The gap between the price paid for raw lithium and the price captured through processing and manufacturing is the same gap that has characterized every extractive industry in modern history. The Atacama communities living above the deposit receive the same fraction of its value as the Congolese communities living above the cobalt. The element is different, the structure is identical. There is an argument that says this does not matter, that what counts is the reduction in carbon emissions, and that the distributional questions of who captures the value can be addressed separately. That argument has been made about every previous resource extraction cycle in history. It was made about oil in the Middle East, about copper in Chile, about diamonds in Southern Africa. In every case, the distributional questions were not addressed separately. They were deferred indefinitely, and the extraction continued. The clean energy transition is real, the urgency is real, and an element forged in the first 3 minutes of the universe, concentrated over 10 million years in one of the most inhospitable places on Earth, is being extracted at industrial scale to power that transition. While the communities sitting above it watch the water table drop, the flamingos decline, and the trucks carry the brine away to be processed somewhere else, by someone else, at a price they will never see. You have heard this story before. The ending has not been written yet, but the first 140 years of it suggest you already know how it goes. So where did lithium actually come from? It came from the first 3 minutes of the universe, forged before any star existed, in a process our best cosmological models still cannot fully account for, in a window that lasted less time than it takes to watch this video. It spent 10 million years concentrating in a desert that receives no rain, beneath a salt crust, in brine pools the world ignored until it decided it needed them. A chemist who had never heard of it isolated it in 1817. A man who had survived a prison camp in Singapore found what it could do for the human mind in 1949, working alone in a converted kitchen, with no funding and no reason to believe he would find anything at all. A 57-year-old chemist named John Goodenough spent the next 4 decades turning it into the battery technology that now sits in every device on Earth, won the Nobel Prize for it at 97, and died in 2023, the oldest Nobel laureate in history, having watched the entire transformation he helped create from beginning to end. And now the world is extracting it as fast as it can, routing the value through the same financial architecture that has always separated the place where things come from and the place where the money goes, and calling it progress. The element is ancient. The story is not new at all. Subscribe if you want more, and leave in the comments. Do you think the clean energy transition can actually be different from every resource extraction cycle that came before it, or is the structure too deep to change?